can edit this out. Okay, so the middle school challenge, as I started talking today, sorry, we got to get your kids together. You got to wait. All right. So this whole challenge is about energy from the sun. Right? And when you think about energy from the sun, and I do that a lot, actually, there's two main ways that you can get it. Okay, in terms of, you can actually go to the store and buy a device that will turn sunlight into energy. And there's two types you can get. There's solar thermal energy, and there's photovoltaic or solar electric energy. The high school challenge I just got done explaining is about changing sunlight directly into electricity, photovoltaic. The middle school challenge is about turning sunlight directly into heat, or solar thermal. Okay. So for the middle school challenge, I'll go back to my incredibly artistically drawn version of a window. Alright, what you're going to get is you're going to get a cardboard box. And you're going to get some paint. And you're going to get some tape. Okay. And your job is to, out of a cardboard box, paint and tape, to make a solar thermal generator. Cool, huh? So when we think about sunlight, have you ever stood out in the sun and felt the warmth of that sun? What about on a really cold day? You guys remember last winter we had the polar vortex, and it was like really cold, and they like canceled school and stuff, right? But if you're inside and it's sunny out, and you stand in the window, do you still feel the warmth of that sun through that window? You know what I'm talking about? Like you stand in the window and the sun's shining, even though it's like 0 degrees outside, that sun still feels warm, right? It's because that sunlight, that light that's actually coming from the sun, is energy. And when that light hits you, it hits your skin, what it's doing, your skin is absorbing that energy and turning it into heat that you feel. It's pretty cool, right? Well, your challenge is going to be to build a thermal concentrator that is able to change as much of that sunlight into heat energy to heat the air as possible. That's your challenge. So, in general, at this latitude, the sun is always kind of south, right? It rises in the east, sets in the west, but it's always pointing south. So you're going to find a southward facing window, and it can be at home, at school, at the Y, I don't know, anywhere that will let you do it, right? And you're going to design a box from your materials that will hang into that window, all right, so that the sun will shine directly on it. And your key is you're going to cover the inside of that box with something that absorbs sunlight really well. So basically you're going to paint it a dark color, because color is absorbed light. That's what it is. You see color because whatever that material is absorbing light. So if you had to pick the most absorbing color, what would you pick? Black. I probably would, right? But it's not just color, because have you ever seen like a shiny black thing versus a kind of dull black thing? Like something that's kind of shiny, you know what I mean? Like some things are shiny, I don't see, oh, like this one. See how there's like a shine coming off of that? Yeah, it's black, right? But it's shiny black. And you see this curtain over here? See shine? Oh, you see, there's no shining. There's not a shininess. It's dull. Anyway, there are different types of paints, right? So one paint will be provided to you, and you can certainly use that one, and you should. It's a good paint. But if you wanted to experiment with some others, you could do that, but you don't have to. Most of this challenge is going to be won or lost. Well, frankly, you're all winners for trying the challenge. But most of this challenge is going to be more successful by the design of this and how well it fits to the window and your design. So what is actually going to happen? You've got that cardboard box. It's covered with an absorbing material. It's on a southward-facing window, and you're going to cut 2 holes in it. Or you're going to cut 2 sets of holes in it. One set of holes that's at the very bottom of the box. One set of holes that's at the very top of the box. Okay? Why? Why are you going to do this? Well, here's your window, in case you didn't know. There's the sunlight coming into your window, and there's the sunlight hitting your box. And I'll take the copper tape off my hand. That sunlight, when it hits your box, if you designed it right, that sunlight's going to turn into what? Like when you stand in the sun, what do you feel? Heat, right? So that's heat. What's going to happen to the air that's trapped between the window and the box? It's going to warm up, right? It's going to get hot. What happens to air when it gets hot?
Rises.
You ever seen a hot air balloon? What do hot air balloons do?
It rises.
It rises. They fly, right? Are you guys bored?
No.
Oh, you're good. You're just helping me. Thank you so much. It rises, right? So if we're heating the air, where's it going to go?
Up the top.
Out the top. Hot air is going to spit out the top. When that hot air spits out the top, what's going to happen at the bottom? Cold air is going to come in. So you just made a heater. You're going to take cooler air from the room. You're going to suck it in the bottom by convection heating. That air is going to warm up in here. When it gets warm, it's going to rise and it's going to spit out the top. You're going to bring cold air in. You're going to spit hot air out. You're going to actually warm the room. Now, it might not work great, but it could. Yes, question?
So this is going to be judged in it?
It is, but it's not going to be judged in real time.
How are we going to judge this?
Good question. So, what you're going to have to do is you're going to have to measure, and the difference is here, you're going to, with the thermometer, you're going to set it next to this air in, and you're going to tell me the temperature of the air in. Then you're going to set it next to this air out, and you're going to tell me the temperature of the air out. You're going to take a picture and record those temperatures. The biggest difference is what you're going for, right? So the bigger temperature difference, in other words, how much you're warming up that air compared to where it started, is going to be essentially the factor you're competing for. All right? So now this is more complicated than it might have first seemed, because what's the best time of day to do this? Right? You're going to have to make sure you pick a good day. Is it in the morning? Is it in the afternoon? Is it whenever? Is it at noon? When are you going to get the most sunlight in from your window? Right? That's something you're going to have to consider. So you might want to think about how do you take a quick measurement at different times, which may be tricky, but you know, I'm just presenting the challenges. I don't know. Or maybe you won't be able to do it at different times, but maybe you'll be able to choose the best day, the sunniest day. Right? So this will be a challenge for that. So one thing if you choose this challenge, you're going to want to make your solar concentrator pretty early on, right, with some time, because you're going to want to have a little bit of time to play with it and to have the right day, right? So make sure you don't wait to the last minute, or you might not get a sunny day. I mean, we live in Ohio, right? Okay. So that's the challenge. And so when you actually come to the competition, what you're going to do is two things. You're going to take this off the window and bring it with you, so we can look at it and look at your design and look at how you made it and the holes and all the paint and all that. So you'll be judged on that. You're going to bring your data. You're going to record your temperature differences. You're going to tell me what day it was. You're going to tell me what time it was and the temperature difference. And you're going to tell me when was the best and what was your best result. So you'll be judged on that. And then you're going to present your process, what you were thinking about, how you made it, the troubles you ran into, stuff like that, and you'll be judged on that. So it's those three factors, the appearance, the data that you bring in terms of temperature difference, and then your presentation. That'll be judged on the day of STEMFest. Okay? Does that make sense?
Are you only allowed to use what's given to you, like the black paint? If you find like some kind of thing that can make it more shiny, can you use that?
Yes, yes. So we will provide a paint for you, but you are allowed to use other types of paints. That is true. And similarly, we'll provide the things, the box. You have to use the box we provide. You can't use a different box. So everyone's got the same shape and amount of material. That's important. But what you do with it, how far away it sticks out from the window, how big these holes are, how far those holes are apart, things like that are stuff you'll have to think about and designing your own material as well as what you coat the inside with. Does that make sense? Yes?
The openings, are they just openings, or what if the students, can they add like a toilet paper tube to make it more tubular?
They sure can. Yes, they can do